Welcome to the deep dive. Today we're jumping into something that looks, well, incredibly simple on the surface. It's this tiny piece of hardware, the Thor broadcast FSDIPG 16 mini pattern generator. But this thing is a real unsung hero in live video, especially when you're dealing with high-speed fiber optics. So our mission today is to unpack what this is really doing. I mean, what is a pattern generator and why is it so essential?
Well, you can think of it as the ultimate quality control checker. It's a quick, simple diagnostic tool before you push that big go live button. This little box ensures the entire signal path, the fiber, the gear, everything is absolutely rock solid.
So it's like a doctor for the broadcast infrastructure. It's not setting the actual content, it's setting tests.
Exactly. It transmits tests, and it's sending 3 very specific signals at the same time to really stress test the system.
Okay, what are they?
First, you have the classic color bars. Everyone's seen those. They confirm color accuracy, signal levels. But paired with that, you get a moving circle.
A moving circle. So that's for checking motion, like no dropped frames or visual artifacts.
That's it, exactly. It confirms motion integrity. And then, of course, there's the audio.
Right, because picture and sound are often separate until they're embedded.
Yeah.
How do you verify that sync?
It sends an embedded 1 kilohertz sine wave, a very pure audio tone. And the specs here are really key. It supports 8 channels of audio running at a 48 kilohertz sample frequency with 24 bits quantization.
That specific combination is what locks the audio clock perfectly to the video clock, I assume.
Guarantees it. It confirms everything is passing through cleanly with no drift. It's all about, speaking the universal language of broadcast. And that language is the SMPTE standards, the 424M, 292M, 259M.
The famous alphabet soup.
Yes.
And that alphabet soup translates directly into raw speed. This is where it gets really interesting for me. This tiny device has to perfectly support bit rates from the full 3G-SDI, which is what, almost 3,000 megabits?
970 milliamps, yeah.
All the way down to legacy SD at 270. That's a huge range.
It is, and it has to do it globally. It supports both NTSC and PLO formats, and you can switch it with a button right on the front.
So it covers everything from 1080p at 60 frames per second down to older PL formats like 625i at 50.
Instant international compatibility right out of the box.
Okay, so the data rates are locked down, but speed means nothing if the signal is noisy. That must come down to the physical side of things, the BNC connector, the 75-ohm impedance.
Precisely. You're hitting on the core challenge here. That hardware is all about maintaining signal integrity. It's designed to combat the ultimate enemy in high-speed digital video, jitter.
Jitter, so tiny timing errors in the digital signal.
That's it. And that raises a really important question. How small do those errors have to be before they actually matter?
I would imagine unbelievably small.
They are. The source material specifies extremely tight tolerances. For 3G-SDI, the timing jitter has to be less than 2.0 UI.
2 UI. What is a UI?
It stands for unit interval, which is basically a time measurement for a single bit at that specific data rate, so keeping the error below that. We're talking about stability measured in picoseconds.
That is just incredible precision. And I guess that explains why you need a dedicated piece of hardware for this, and not just some software on a PC.
You absolutely have to. You need a dedicated, physically stable clock signal. If that jitter gets too high, it's not just a fuzzy picture, it's catastrophic signal loss on a live feed. This little box is what prevents a multi-million-dollar mistake.
Amazing. So this device, just 93 millimeters long, is basically the gatekeeper for these massive high-speed broadcast systems.
It is. And if you think about the big picture, the reliability of almost every single broadcast you watch depends not on the beauty of the camera, but on the precise, measured output of a simple color bar generator just like this one. So what this all really means is that professional quality is defined by minimizing those error margins to almost nothing.
A fantastic deep dive into the engineering that makes it all possible. Thanks for guiding us through it. We'll catch you next time.